Hi guys, welcome to Ignite India online classes. This is the biggest channel for any kind of entrance exam preparation. Today we have Mr. Nand sir with us, who is an XLRI postgraduate, and he will take the class on quantitative aptitude. We welcome you here, sir. You can start the session.
Thank you. Good evening, guys. Wave. When I say good evening, it's good to wave. All those who have all those who have the video on. Right. So we're going to continue with our session, and you know what the session has been all the way. So today's class is going to be on HCF and LCM. Pretty small topic, but can be impactful, especially when it comes to any kind of an exam that we are talking about, right? Okay, all right, begin. Right. A thumbs up again if you are able to see the screen. Thank you. Right, so as we are talking to numbers, HCF and LCM is what we begin with. So what do we mean by an HCF? We all know what HCF is, right? So HCF means highest common factor, and LCM means a lowest common multiple. So I repeat here, I know that I have done this, I think in the two classes before this, but again we will discuss factor. So how do you define factor? Factor of n are those numbers, or R or E's I can put, those numbers which can divide n, right? So take any number in your mind. Take any number in your mind. So if you're basically saying that, let's say my number is 12, right? So now think of a number that can divide 12. So you all know 1 can divide, 2 can divide, 3, 4, 6, and 12, right? So all these numbers, since it can divide 12, all those numbers, that is 1, 2, 3, 4, 6, and 12, they all become factors of 12. So factor of n is or are those numbers which can divide n. Okay, and we know that when we say divide, we are basically talking about no remainders. Okay, so I can see 4 people in my screen, right? Sanika, Anushka, Sarah, and Nirupama. So you got to give me a hand, a stop signal when you cannot hear me, right? From your hand, don't shout because I can't hear you. So from your hand, show me a stop signal when you can't hear me, right? So that's basically the factor. Now, what do we mean by multiple? Multiple of n is or are those numbers which n can divide. So if you actually see the difference between factors and multiples means, in factors, I'm looking at numbers which can divide n. And in multiples, I'm looking at number which n can divide. Understood the two differences, right? So I know that 12 can divide. What all numbers 12 can divide? 12 can divide 12, 12 can divide 24, 12 can divide 36, and so on and so forth, right? So because of this, these are called as the multiples of 12. Now, why are we in search of the lowest in this case and the highest in this case? We say highest common factor. We don't say lowest common factor. And we say lowest common multiple because we don't say highest common multiple, right? Now, why are we looking into the highest and the lowest number? Because When you look at factor, I know 1 is factor of every number, right? So when 1 becomes factor of every number, 1 becomes the lowest number. So if someone says what is the lowest common factor, the lowest common factor will always remain 1, no matter what you do. Because 1 divides all the numbers and there is no number below 1 which can divide, no natural number, right? And thus, you never find the lowest common factor, you always find the highest common factor. And why don't we find the highest common multiple? Why are we searching for lowest common multiple? Because when you look at multiples, there is no limit to the upper end of it. For example, when you're looking at 12's multiple here, you started from 12, but there is no limit. You can go as high as you can, or you want to, right? So since there is no limit, I will not look into highest, I will look into lowest, because the lowest is the limit that creates from where you begin. So it's always the lowest common multiple and always the highest common factor. Got it, guys? Shall we proceed? Right. Now, let's understand how do we find LCM and HCF. Though there are lots of people who know how to find LCM and HCF, this is kind of a revision for many people and probably maybe some ideas that we can generate. So let's take from small ones to understand if I want to know what is the LCM or HCF of 12 and 16. Typically, school days, how we used to do? We used to take 12 and 16 and divide it by a common factor. So I know that 2 6 are, I know 2 8s are. Again, I know 2 can divide, so 2 3s are and 2 4s are. Now, there is no common factor between them. So now because there is no common factor, we stop here. And thus, whatever we multiply on our left-hand side, so this product that we multiply becomes the highest common factor, because these are the values which are common as a factor available with the values given to me. And thus, my highest common factor becomes 4. Right? Anyone has a doubt, please do raise on the chat box. Okay? Now, so this is your highest common factor. Now, what do I do for a highest common or lowest common multiple? I continue dividing them, right? So even after getting 12 and 16 with 2 and 6 and 8, then with 2, 3 and 4, I continue dividing this. And because 2 doesn't divide 3, I write 3 the same way it is, and 2 2s are 4. And again I divide 2, 2 doesn't divide 3, so I write 3 as it is, and 2 1s are 2. And now I take 3 and 3 1s are 3 1s are. So basically, I keep dividing till my last value is 1 1 1 1 1 1. Right? So once I do that, and then whatever I get on the left hand side, if I multiply them, that becomes my lowest common multiple. So 2 into 2, 4, 4 2s are 8, 8 2s are 16, 16 3s are 48, becomes my lowest common multiple. Right, guys? So that's how we used to calculate highest common factor and lowest common multiple, and that's how you calculate the HCF and LCM even for other numbers, right? So let me quickly give you another. You guys have to tell me this, okay? So if I'm giving you 96, 144, and let's say 216, can you tell me what is the HCF and LCM of this? 96, 144 and 216. Ajay, HCF 12. Okay. Let's see. Let's wait for others to answer. So we basically do 96, 144, 216. Now remember guys, you need not always start with 2. Okay? If you feel that the number is divisible by 4, you can start with 4. If you feel that the number is divisible by 6, you can start with 6. You need not start with 2 always. Okay? We do it with 2 because 2 becomes easy. But if our calculation is good, right? If we know multiplication table of certain numbers, then we can start with certain numbers. Like let's assume that I start with 6. So I know that 6 ones are 6, and then 36, 6 6 are 36. And I know 6 2s are 12, 24, 6 4s are 24. I know that 6 3s are 18, 36, 6 6 are 36, right? So I do this. Okay. Now, let's wait, Kavya. I'll just check. Even I do not know. So 6, 12, 36 becomes my first division. Now I know that since all of them are even, I can divide by 2 further, and then I'll have 2 8s are, 2 12s are, and 2 18s are. Right? Am I right till here, guys? Right. Now do you see that that's still common? What is common? 2 is still common. So I can take 2 again and say 2 4s are, 2 6s are, and 2 9s are. Now this is where I will always come and stop, because now I don't find anything common. So I cannot divide further with one common factor, and thus my common factor becomes 6 into 2 into 2, which is 24. So HCF becomes 6 into 2 into 2, 24. I hope all of you got this, and those who didn't, I know that you have figured out where you went wrong. Okay, that's important. Now, for an LCM, what am I supposed to do? I'm supposed to continue dividing it, right? Now remember, when you cut it to an LCM, you got to start dividing it by the smallest common factor. Okay? For example, here I will start dividing by 2 and not by 4. Though my intention is to bring 1, 1, 1 in the bottommost, I will never start dividing by 4, 6, and 9. Okay? I will divide by 2. I get 2 here. I get 3 here. I get 9 here. I will again divide by 2. I get 1 here. I still retain my 3. I still retain my 9. Now again I divide by 3. I retain my 1. I get 1 here, and I retain my 3. And thus I further divide by 3. I retain my 1, and the 1. So now my intention of getting 1 in all the cases has been satisfied. And on my left hand side I have values, right, which are now nothing but the LCM. So what is my LCM? So I knew that 6 into 2 into 2 was 24. Now I have 24 into 2 into 2, that is 4. 24 4s are 96. 96 into 9. So what's 96 into 9, guys? 800 and? Can you type in? If you speak that, I will not know. So you got to type in. Okay. So 864. Right. So that's my LCM, right? So 864 becomes my. Right. So 864 becomes my LCM. Right. Now again, a quick one here, guys, to all of you. I would like to tell you something here. Now that we have touch based. See what you tried to do? You tried to do 96 into 9. Now most of you would have done this, right? 9 6 are 54, 4, 5 carry, 9 9s are 81 plus 5, 86. So one is this is where you calculate. The other way, if you want to calculate without writing this, is do 90 into 9, which you do not need a calculator or a pen for it, right? Because you know 9 9s are 81, so 90 into 9 is 810. And then you do 6 into 9, which is 54. So 810 plus 54 is 864. You know what happened? I split 96 as 90 plus 6. That's all happened. Okay? So you can do this also as a part of your calculation so that you get used to it. It's not going to make much difference in this case, but it may probably help you a lot in the different one. So So what we found now? We found that LCM and HCF of 96, 144, 216 is HCF is 24 and LCM is 864. Okay. Now let's get into, so this is one way of doing it, guys. So if you are all comfortable using this method to solve HCF and LCM, proceed doing that. Now I'll come back to the same question and let's see what happens. What is there some other way of doing an LCM and an HCF? So another way of doing LCM and HCF is when you break down the values, okay? For example, 96, I know is 2 into 48, correct? Right. Now let's remember the word number 48 in your mind. 48 is 2 into 24. Now remember the number 24 in your mind. 24 is 2 into 12. Now remember the number 12 in your mind. 12 is 2 into 6. And 6 is 2 into 3. Am I right? Not much of a difficulty? Okay, let's do it again. 144. Remember in your mind. 2 into 72. Half of it, right? Half of 144. 2 into 72. Now take 72. 72, we all know is 8 into 9, but still, let's assume I have to do it with the basis of 2. 72 is 2 into 36. 36 is 2 into 18, because 2 means it's basically half of the value. 2 into 18. 18 is 2 into 9. 9 is 3 into 3. Right? And now 216. 216. 2 into 108. Half of this. Half of 216 is 108. 108. 2 into, what is 108 half? 54. 2 into, what is 54's half? 27. Now 27 is not divisible by 2. So 3 into 9 is 27. And 3 into 3 is 9. So what I have done is, I have split all my values into its prime factors. Why did I use the word prime factors? Because all the factors here are prime numbers in your hand. Okay, so you used as a prime factor. Done. Now once I have done that, now what does highest common factor mean? Highest common factor means that the value should be common among all the three of them. So what are the values which is common between all the three of them? The 2 is common. The second 2 is also common. The third 2 is also common. But the fourth 2 is not common in the third one. Okay? Now, so 2 is out. How many 3's are common? Only one 3 is common. So what is the value that is common? So that's your highest common factor, because these are the only values which is common in your hand. Got it? Okay. Now, what else do I have to do for an LCM? So what should I do for an LCM? For an LCM, it is slightly different from an HCF. What I have to do is first write down what are the various prime numbers do you see in all the three values that you have in your hand. In all the three values that you have in your hand, the prime factors that you see is 2 and 3. Okay. Which number has the highest power of 2 available with you? If you see, both 96 and 144 has highest power of 2. Both of them has 4 2's with it, in it. Right? So pick the highest power of 2 and write it down. Pick the highest power of 2 and write it down. Now, what is the highest power of 3 that you see? You realize that 216 is the value where you have the highest power of 3. How many? 3 3's. So write the highest power of 3. So what do you have in your hand now? 2 power 4, 16 into 3 cube, 27. Did I miss something? Yeah, someone's nodding, so I have missed something. Yeah, what did I miss? Trying to understand here. You can unmute and say.
Sir, in 96 there is 5-2.
Kisme?
Sir,
Oh,
96 में.
I didn't see this. Sorry. I have to improve my power of glasses now. Okay, so I didn't see this. Right, so there are 1, 2, 3, 4, 5. 5 twos. Thanks, Rimchip. So that's 32 into 27.
Sir, it was
And-
Anushka.
Sorry?
It was Anushka, not me.
Okay, Anushka. Thanks, Anushka. So that's 32 into 27, and that's the value that we have found in the previous figure also. So all you have to do is, for HCF, the common factor, right, which is common across all the numbers given. And for LCM, it is the highest factor of all the prime factors that you have, of all the prime numbers that you have. Okay. I'm just taking a minute time here, not a minute, few seconds time here, because there are some people who put a chat. Okay, who's that who has put a chat? Karen says, so basically HCF is lowest powers multiplied and HCF is highest powers multiplied. Absolutely, Karen. So lowest powers, that is common. Okay, Karen? So lowest powers, which is common, and highest power, which is available. So that's what it is. Thanks, Sheetal. So now this is your HCF and LCM. Now coming to the next one. So there are certain questions where it says if you have fractions. So we know A by B, C by D, E by F. Let's say this is a fraction. So how do I find LCM of a fraction? LCM of a fraction is always LCM of numerator divided by HCF of denominator. That's how we are going to find LCM of fractions given to you. So if someone says what is LCM of 2 by 3, 3 by 5, 5 by 7, then it is LCM of the numerator divided by HCF of the denominator. So basically LCM of A, C, E divided by HCF of B, D, and F. And what would be the HCF? Nothing different, it's the same thing. You got to take the HCF of the numerators and divide it by LCM of the denominators. So it's HCF of ACE divided by LCM of BDF. Got it, guys? All of you? Right. Okay, so shall I proceed? Vinti, you able to understand? Fair enough. Okay. So let's get into the next one. Now, with HCF and LCM in our hand, there are certain things that happens and certain properties that happens. Okay, so I will come back to this sheet and erase this because I need the space. Now let's take this. Oh, okay. So let's begin with a very simple example again. We started with 12 and 16 earlier. So now let me talk about a 24 and let's say a 36. Okay, so let's start with these two. 24 and 36. What would be the HCF of 24 and 36? I want you guys to don't type in the answer. Don't type in the answer. Just work out and keep it aside. What is your HCF and what is your LCM for 24 and 36? What's the HCF for 24 and 36, and what's the LCM for 24 and 36? Okay, just show me a thumbs up if you guys have done it. Right. Not many thumbs up coming up. Okay, okay. Right. Okay, guys, done. So, okay, all right. Now let's look into okay, so let me get into this now. Now that we have found the HCF of 24 and 36, I'm sure all of you got HCF as 12, right? And LCM as 72. Yeah, great. Now, so basically look at these numbers 24 and 36. I realized that 24 is made out of 3 2s and 1 3, whereas 36 is made out of, you know, 2 2s and 2 3s. Okay, so I realized when I look at them that the common factor, the highest common factor, is the 2 2s, because 2 2s is common in both of them, right? And 1 3, because 1 3 is also common in both of them. So from this number, if I remove 2 2s, I am left with 1 2, and if I remove 1 3, I am not left with nothing. Similarly, on the right hand side number, if I remove 2 2s, I am left with nothing of 2, and if I remove 1 3, I am left with only 1 3. Right? So basically, when I remove my highest common factor, from these two numbers, I am left with two numbers which do not have any common factor. Right? Two numbers which do not have any common factor. And please remember that two numbers with no common factor are always called as co-primes. Okay, this is an R, please understand. Co-primes. So when there are two numbers which have no common factor, they are called as co-primes. The word co tells you that these have to be only two numbers. It cannot be more than two. Okay, that is the rule. The word co means that these numbers are only two in nature. They are always in a pair. They cannot be more than two in this. Though, for example, 3, 5, and 7, you realize that all these three numbers do not have any common factor, right? But they can't be called as co-prime because they do not exist in a pair. So for any number to be called as co-prime, it has to exist in a pair. Did we understand this, guys? Nihar? Clear? Oh, great. Right. So you always look into this, and now that you got your HCF, which is 12, look at your LCM. What happened with this LCM part? Okay, look at your LCM. Your LCM invariably became nothing but the 12, which is the HCF, multiplied by the 2 and the 3 that was left over. See your LCM, 72. Your LCM became nothing but the HCF that you had in your hand, multiplied by the 2 and the 3 that was left over with you. So what happened? 12 into 6, 72. Right? So thus, what we can also, so if I have to generalize this, right? So if I have to generalize an LCM and an HCF, so how do I do that? So I'm changing this particular screen now, assuming that you guys have understood this. So how do I do that? So I can always say, okay, don't write down the left-hand side. We will write down that left-hand side at the later stage. I can always say that if there are two values, let's say 12 and 16, the two values can always be written as a product of two numbers where one of the number is the highest common factor. If there are two numbers 12 and 16, I can write these two numbers always as product of two values where one of the value is a highest common factor. All right. Once I remove my highest common factor of 4, or once I remove my highest common factor of h, then I will always be left with two such values which do not have any common factor, which means two such values which are coprimes. And once I am left with two such values which do not have any common factor, my LCM will always be the highest common factor that I have found multiplied by the two values that was left in my hand after it. That is always going to be my LCM. Highest common factor that I found multiplied by two values which I am left with. And what we should not forget is that the two values that are left are nothing but co-primes. So this information we should not forget, because this will help us in solving a lot of questions. Okay, shall we proceed, guys? Right. Okay, for once, can I get a yes from all of you who's attending the class, so that I know that in a chat box, so that I can proceed further. If you have doubts, please say no and shoot your doubt. And if you do not have a doubt, press yes, so that I know that you're alive and kicking and not sleeping. Right. So, Rimjim, you can check the number of yes versus the number of participants. The head count will come.
Yes, I'm doing it. 1, 2.
Okay. You अपने आप से कर लेना, मैं नहीं कर रहा इसलिए बोला. All right. So we are proceeding further. Now let's assume a question. Okay. I don't want you to sit and solve this, but let's read the question, understand it. It says product of two numbers is 384 and their HCF is 4. How many such numbers exist? Okay. How many such numbers exist? So now, just a minute, sorry. कहाँ गया? Right. So product of two numbers is 384 and their HCF is 4. How many such numbers exist? So I don't want you guys to solve. Let me solve it for you. And then the next question you can solve. Now look at what happened here. Okay, I want you to concentrate on this portion that I'm circling right now. Because this is the portion that we are going to use, along with the one that I'm circling in black. These are the two portions that we are going to use. So we said that if there are two numbers n1 and n2, both these numbers can be written as a product of HCF and another number, product of HCF and another number. This is what we said. And we also said that once the HCF is left, then we are going to be left with two numbers A and B, where the basic condition of A and B is that they are co-primes. Okay, the reason why I keep repeating this word so that it just remains in the head and we don't do silly mistakes here. And I also know that HCF is nothing but your H and LCM is nothing but your H into the two leftover numbers. Now I'm going to look at the question. The question is saying the product of two numbers is 384. So basically N1 into N2 is 384. That's what it is. Now if N1 into N2 is 384, then I know that N1 and N2, both of them can be written in the form of H into A and H into B. So I can write this as H into A into H into B is 384. So what is H for me? H is nothing but the HCF. And do I know the value of HCF? I know the value of HCF is 4. So I can say 4 into A into 4 into B is 384. Now guys, please understand.
Can I stop you in the middle?
Yes, please.
Guys, can you please rejoin the link again? Everyone who is here, just click on the link and rejoin, okay? Please. Thank you. I'm just stopping this here.